All right, so I'm looking at R programming. This is part two of the basics, the very basics. This is part two, and I'm doing this video specifically for the fact that I've noticed that a lot of those who are following me or who are subscribers are not too conversant with this. Some of them are new, they don't know anything about R, so that's why I'm going back to do this basic stuff in R. Which is also very useful if you're also a beginner or if you are starting. So I'm going to share my entire screen, and then I will be alternating between my screen, my RStudio, and then that of my slides that I have prepared to be able to do this. Alright, so I'm going to pull up my slide. I have quite a number of them here. So in the case you are going to set up your R environment, this is how the R environment looks like. Before you watch this video, watch the previous video. R from ground zero. After you watch that particular video before you can watch this, that is going to give you some grounding. So we've set up our R environment already. We've downloaded our R, and then we go ahead and then we download the RStudio as well. Then we've launched our RStudio, and then we have created a script. We named the script, and then now we are now going to the next stage. And the next stage is where we are going to look at all these things. So we have R command prompt. We can have it as $1. We can have it as this. We can also have it as $1 like this. The command prompt is not actually, don't worry yourself about changing it. Just allow the default prompt to be there. And then of course we also have these two things that I'm going to. There's a difference between print and then cut. When you are printing the content of a variable. If you are cutting, you are just printing the text just like the way it is. So like I said, I'm going to be alternating between the RStudio, and then I have a whole script that I am doing that has to do with so this is where that particular script is. So I'm going to pull this like this, and of course somebody is telling me that my font size is quite small. So this is how we increase the font size. I'm going to come here, you go to help, tools, you go to global settings, and of course you can come to appearance, and then you come and change the font size to this. And when I'm done, I'm just going to come here and say I'm just going to pull this up. Let me pull this up. Okay, then try pull this up. Then I'm going to say apply, and then okay, yeah. And so this should be able to finish up. Okay, and then let me try and see if I can. I think anybody who is watching should try and help me anytime at all that I try to do this. I try to make sure that I can. Okay, so how to be able to get this off my screen is always a problem to me. I don't know how to be able to do that, because I just can't scroll it. I can't just take it up to anywhere again. So now, okay, maybe I should try something and see. I cannot just shift this up any longer. Is there a way to be able to do that? I don't know. Okay, maybe I should use escape, and that will help me. All right, thank you. So I'm coming here. So because we are doing learning, when you come here, you just brush off, you take off everything that is here. And so now I'm good to go. This is actually where I'm going to be running most of the scripts. So let me fold this up. No, not that place. I'm going to just have. So I was talking about the fact that, so the last time we learned about like variable creation, and so what is it? So I'm going to create just a variable. I can just say what is it, my data, or I can just say data, or I can just put it this way, and then variable creation, you remember how it is. So let's say that I have a variable that I'm going to create. So I'm going to create a vector. So I'll use the combined sign to be able to create a vector of some numbers to like 22, 34, 66, 7, 4, and then let's say 78. So when you do this, if you run it, it is not there like that. Now, what is the difference between print and then cut? Now, if I come to write here, print, you see, it's going to ask me, what am I going to print? I'm going to put the variable name there, which is the data. Now, if I was to run this, it's going to print the content of the variable. And the content of the variable is what we have here up to this point. So it's going to print this 22, 45, 66. You see, that's what print does. So you see that it prints those, numbers around here, or it print the content of the variable, which is the vector. Now, this is different from cut, like something like this. Now, when you are cutting something, you are printing a text, all right? So, for instance, if I should do cut right now, it means that I'm actually going to print a content or like a text. So, for instance, let's say we are learning R programming or R programming. So, if I should run it like this, you see that it comes to print exactly the text that we have here. So that's the difference between print and then cut. And that's what I was talking about. So if I pull up here, so that's what I was talking about, the difference between these two functions and then around here. We also have another one called run and then rerun. So if I get back to RStudio, so this is what we call run. The run means you commit whatever that you have written into R memory, so that if not, if I just should put, let's say if I should just create a variable right now and call it data1, and then I just say, let's say this. Okay. So if I do it like this, it is just a text here. There's nothing in it. But if I run it, then it means that I have sent this particular variable into this. I've sent this particular value or this particular object into this variable, and that's all that I have done. So the run commits whatever that you have, the text that you have written, into R, and then R will take it and then manipulate it and then keep it the way you have access to do. And so that's what run will do. Rerun means run the thing again. So maybe let's run, and then that is it. So let's come here and rerun. The rerun means it will run it again. It will run the same line again. It runs the line that you have just run immediately, and that's what that is all about. So we also have copy, and then we comment out. Then we have block commenting. So let's look at what that means. You copy and then you can comment. So now if we are going to copy, we can copy the whole of this, just like the way we copy in Microsoft Word. Here I've highlighted. Control C, I've copied the whole thing. I can come here and then Control V, it will paste. It's just the same way we do in Microsoft Word. So we can copy and then we can paste. So what do we mean by comment? To comment means that to say that that part of your text is not a code. For instance, I've written what we have here. So I'm going to copy this, and then I'll just come here, and then I'm going to just paste it. So I pasted it. But I want to explain what it is here. So I can just put something like a hashtag. So if I put a hashtag and then I say this is how to create maybe a vector. You see that part of the code is highlighted green, and then it is telling us that right after the hashtag, immediately anything, when you write anything on the right hand side of a hashtag, it's a comment. So R doesn't consider that as a code. So when you run, R will only read the code from here all the way up to this place. But anything from the hashtag, after the hashtag going, then you won't be able to do anything there. And that's what I mean. Then we also have an instance of, we also have what we call, this is commenting. You are just commenting one line. So what about if you want to comment maybe a bunch of lines, like you have so many lines, so you want to comment them out. So you don't want to run those lines again. In any case, this particular line we're having here, if you wanted to comment it out, we just come and then put your hashtag there. So Shift and 3 on your keyboard is going to, so when you move it, the hashtag is not there. But what about if you want to comment a whole lot of lines? So I have some lines here. So you see I've highlighted all of them. So when you want to comment a whole lot of lines, there are many of them, highlight those particular lines, and then you do Control plus Shift plus C. It will comment all those lines out. Let's go and demonstrate that. So I've highlighted these 4 lines, 1, 2, 3, 4, and so I'll do my Control Shift and C. It will comment all of them out at once. Okay, and that's how to be able to do it, because there are instances you have a whole course that you are not interested, like particularly a whole page. What do? You comment them out, and you can't have time to comment here, go comment here, go comment here. That will be a whole lot of hell. So you just come here. If I want to take all the comments out, Control Shift and then C again, it will take all the comments out, and that's how that works. And then of course, what's the next thing? R flows using the board mass principle. Functions come before argument, and functions do not have spaces between them. So let me demonstrate this. R follow board mass principle. So let me get back to RStudio and then see whether we can demonstrate that. So we know something we call board mass, right? So because I'm going to board mass, board mass. So here you are going to, if you have anything at all, the bracket is what it is, what is that works that you have to deal with first. So you work out your bracket, then before you follow by division, follow by multiplication, follow by addition, and then follow by subtraction. All right. So let's say if I have 34, let's say plus, let's say 23, and then let's say I put it divided by 34 plus 23. If I run this, it's going to give me 57.67, as you can see down here. Now, what about if I decide to put parentheses? If I put parentheses here, then I come here to put. Okay, now let me leave it this way and run it again. You see, now the answer is 24. What is it? 0.67. Now, what about? Let me copy it, and then I'm coming to paste it again. So what about if I decide to put the two of them in parentheses? So I decide to close this up, and then I close this up, and then again I go to run it. If I run, the answer is what? 1. You see, so what it means is that R is going to work on the bracket first and put the answer there, come and work out this outside, and then it will divide the total answer here plus the total answer here. So it's going to work on the bracket first before it can follow by the division, before it will follow by, if there was subtraction, it will work with that first. So that is what R follows. But let me say that in R, we don't just follow the board mass strictly. It's always, you are looking at the bracket. So you are looking at the BO first, and then you follow by exponent. You see, then follow by, you see that exponent has already come, but that's not what we are. So follow by division, follow by multiplication, follow by addition, and then follow by what is it? Let me say subtraction. This is the syntax R follows. So it means that if you are writing any function, then you should know how to be able to schedule your function. For instance, I want to calculate the root mean square of, let's say, a figure. Root mean square, this is root mean square error. And so I have already seen the error. Let's say that the error is, let's say the error is somewhere, let's say 23. And I want to calculate the root mean square of this particular error. So how do I do that? So it means that we have to find the root, the square root, and so this is square. This is my square root first, and then this square root I have to open up, and then find out the mean. Okay, and then if after the mean, I also need to find out something again, and then I am finding the root mean square error. So where is the error? The error is 23. So I have 23. I will now have to put it inside here, and I need to square the 23. So how do I do that? I now put my something here like this. This is the syntax, how you are able to to do it. And then this time around, if I do, it's going to give me practically the same thing as this. Now let me bring out this. Let me bring it out here. So this is the mean. We are going to find the mean of this. Obviously, it will be useless because it's only one value. And so I'm going to say like this, raised to the power 2. And then let's run it again and see what will happen. It's still the same. So, but I'm just trying to let you know, let's say that we were having this mean, and there were quite a number of them. Let's say I have another this, another something, another. And so it means that what we are going to do is it will work on the bracket first, the inside one first. You see? Then after that, it will square it. Then find the mean of it. And then after that, then it is going to come with the square root. You see? So that would have equally been the same thing. Because of the square root here and then the square here, that is what is cancelling each other. All right. But just wanted you to see how the syntax works. And then, and that is it. Now let's get back to our syntax here. So R follow board math principle. Then functions. Functions come before argument. Now let's go and demonstrate this. In R, the basic syntax is that you have a lot of functions and the function must always come before the argument. What does it mean? I just wrote something right here and I call it a function. So there are so many functions like a mean. A mean is a function, right? As you can see it here, a mean. So I want to find a mean of some set of numbers. So let's say I have 21 and then I have 23, I have 24, I have 15, I have 65. If I want to find the mean of that, then it gives me the mean is 21. So what I mean is that the mean always comes, the function, so the mean here is the function. It comes before the argument. So here, these are the arguments. If you had written all this, you cannot say, you could not have had this before. Let's say I have it like this. You come and paste it here, like this, and then you now come and write mean here. No, that's what I'm saying that. Okay, you see that the syntax will not even allow you. You can see this red symbol here tells you that it is not correct. You can't do that. Okay, and then that's what I wanted to put across as well. Then what is the last syntax that we need to pay attention to? So we need to check. So functions do not have spaces between them. Yeah, most functions in R do not have any space between them. For instance, if I have, let's say read dot CSV CSV is a function. This allows us to be able to read a CSV function, what is a file. Now you cannot keep any space here. If you put a space here, then the function will not work. That's what I mean. There can be a space between any function. There are some functions that will have underscore. Leave them like that. There are some functions that will have a point. You have to leave them like that. But you cannot create any kind of like a space in between them. Another thing is that when we are creating a variable, let's say I want to create a variable 3, like this. Let me put some space there. And so I want to say my data 3. You see that this assignment operator is also a function. So the less than and then this dash, the two of them come together to give us an operational assignment operator. You cannot create a space between them like this. No, you cannot do that. You can't create a space. When you create a space, it doesn't save that particular function. And that's what I mean by you cannot have any function And so you see that functions do not have spaces between them. So that's what I mean by these are the basic general syntax of R. And then what is the next thing to do? We want to look at R variables, which we have already looked at. I don't want to bore you with that, but let's look at data types. In R, there are so many data types that we can think about. And so let me move a little bit. So for the variables, we've already looked at variables. The variables are simply what we create, like data 1, data 2, and then how to be able to create variables. If you watch the other video, I demonstrated how to be able to do that. So now, and then we have this syntax as to how to create variables. Now this is variable name, this is valid. Now you can use underscore. If you watched my previous video, you will see that they are there. This is invalid. You cannot create a variable with this kind of modulus. This one is invalid. Why? Variable does not start with a number. You cannot start. You can start variable with a decimal or a period. This is valid. You can see the invalid and you can see the valid ones around here. Pause the video, recheck all this, and then you are good to go. Now data types. So R has a way of taking its data. And then here we want to look at vectors, we can look at list, we can look at data frame, we can look at matrix, and we can look at, let's say, data array. Now, all these data types are the data type that R is able to recognize or R is able to work with. And so when you have your data, if you collected your data, you have to either put it in one of these structure before you can read it, or before you can bring it to our environment and work with it. All right, so let's begin and look at some of the data types. So I'll come here, and then the first one we're going to look at is vectors. See, and so the vectors, we are simply saying that a vector is a sequence of data elements of the same basic type. That's what I wanted to pay attention. A vector. So the first data type we're going to look at. So this is where the hashtag thing comes in. So we're going to look at data types. And then what are we going to look at? We are going to look at vectors. And so when we come here, let's say we want to create a vector. So we can create I can call this my vector 1. And then now the vector 1 this is the variable. And this what we are now coming to do. The argument is what defines whether it is a vector or is a list. Now to create any type of data, there's a function you use in doing that. When you are creating vector, it means that a vector, you have a series of values which you want to put them together. They are of the same type, the same category. Either they are numbers or they are characters or they are booleans or whatsoever. That's what we mean by they're of the same type. So let's create a vector of numbers. And so I should have put the variable to also, so this is a vector underscore numbers. So if I come here, what function do we use to create a vector? You use the combine function, that's C. And so I'm going to put here into bracket. So if I immediately RC sees, it knows that what you are creating is a vector. And so the function is combined, but we shorten the combine into just C, lowercase. So I want to create a vector of numbers, which I've already done. You can see there's one here. I'm just going to copy that. And then I can just come here and come and put it there and then paste it. So I've created a vector of numbers like that. So what is it? They are all there. All that R knows is that this C here means that you have created a vector, and that's it. So we can also create a vector of characters. A vector, and so I'm going to say, what is it? That's going to be my vector. And then I'm going to call that vector of characters. And then so it's still the same C because you are creating a vector. As long as you are creating a vector, the function to create a vector is always the combine function, so that you give it C. I was saying that there's no space between functions. Function, there's no space. So the whole of this, you can't put space, but in between the function and another function, you can put as much space as you want. For instance, I can shift this like this, there's no problem. There's no problem. But I cannot shift this. No, I cannot do that. That's what I mean. Now, another thing is, in creating a vector, the entry or the values or the objects which you have, or the argument here, like we have here, those are the objects. They are always separated by commas. They are separated by a comma. You cannot separate it by a space. You can't, for instance, I cannot leave here a space here. No, arrow would see the space as a character. And then let me run this and you see what's going to happen. Yes, they will say that, arrow will say that there's an unexpected constant. And so it is this particular space that you have left it there. So the best way is put comma there and you have no problem. And then that works just well. Now, so let's go to and look at the characters. To create a character, arrow was created for numbers. So to create a character, you have to identify it with some double quotes or single quotes. So here, what is it? You do your shift and 9, you open your bracket and close at the same time because it is inbuilt. And then what am I going to do? I'm going to create a character of, let's say, people's names. So you can either use double quote like this, single quotes like this. And so here, let me create those characters of people names. What is it in my village? Then I come out. Then I'm going to do another one. Let me just put some few people. What is it? Don't work over there. And then okay. And then I have to immediately you press on that single quote. The double will automatically come because you are using a function and arrow knows what you are about to do. And then so here I can just say I'm talking about combats, and then I can just come here and I can just talk about let's say Kwanlang, and then maybe I can leave it here. And then let me add another one, and then I'll put that one Tanjung. Now I've created, these are characters, so you see that you run it, it's going to run properly. But you see that they are all having apostrophe 1111. But what about if I wanted to say Dunwax? Let me copy the whole of this, and then I will demonstrate something for you to see. So if I come here, let's say I have a vector of, let's say what is it, character 2, and then let's say I have this, and then this, just put it inside. Okay, so let me take this out. Let me take this out. So yeah, so that's just okay. Now let's assume that I wanted to have an apostrophe. So I say maybe Dunwax like this. Now let's run it and see what is going to happen. You see that arrow does not accept it. You know why? Because there's an apostrophe here, then there's a single quote here, another single quote there. So what I always recommend is that R can take single quotes to create characters. It can also take double quotes. I always recommend that use the double quotes because of the apostrophe. Wherever you are writing a text and there's a possessive there where you need to use an apostrophe, it conflicts with the quote that is separating the characters. And in that case, you're going to have a problem. You're going to have this kind of problem. But now let's assume that I have, let's say, what is it? A vector underscore. Maybe let's say I have a character 3, and then I have my C here. So I'm just going to paste whatever that I copied initially. But in this case, I think I just have to create all of them at the same time. I have to create all of them at a go. In this case, if I have double quotes here, and I can put that place dudes, and then I can just come out here, then you have the double quote. Double quote is shift and then the key, which is close to enter key on your keyboard. And then I have, let's say, the work. Okay. Then let me come out. Then my double quote again, and I have combats. Don't actually worry about the spelling. and then I have Kwanla, and then I just have, let's say, another double quote again, and then the last one that I'm going to do is Tanjo. Now it's the same thing. Now let me come to the same don't work and put a possessive there, don't works something. So in that case, I'm going to put one single quote and I'll put S there. Then run it and then see. You see that that runs properly. So this is the reason why it's always good to use the double quote. In the case of a name that has possession, let's say there are a group of people that you are trying to identify, it's always good to use the double quote so that you are free to use your apostrophe. This is what I wanted to demonstrate. All right. So now we've created our vector of numbers. We've created our vectors of characters. Let's create a vector of, let's say, Boolean. And the Booleans are simply, so I have a vector underscore Boolean. And then the Booleans are usually true or false. So I want to create a vector of either true. So I'm going to write true. And pay attention to something. And I'm going to write false. The false comes. I'm going to write T again. That comes. And I'm going to write F again. That comes. Now, have you noticed that there are also characters, but I didn't put them into double quotes? It is because true, false, T, F are inbuilt. They are functions that has already been built in R. So anytime R sees T, it means that you are talking about true. When it sees capital F, it is talking about false. It's the same thing as the false we have here and the true we have here. You cannot spell the true in small letters. You can't spell the false in small letters. If you are shortening them, they have to be in capital and then in that order. For instance, if I should say something like true, you see that the color will not change. And that's what I mean. So if I do like this, I have already, there is an error somewhere. Object vector on the Boolean not found. Okay. So I always say when you are doing data science, always never be afraid of errors. Errors allow you to see where you have small problems. You know where this thing happened? This is incomplete function. You see that I put only the less than sign. I didn't add the dash to complete it as an assignment operator. So I needed to come and do this. So that would have completed it. And so in this case, now when I run it, it will just run properly. And then you see that now it runs just okay. And so this is how we are able to create our our vectors of Booleans and characters and whatsoever. We could, and then that's vectors for you. Now let's look at lists. Let's go and then look at how to be able to create. You can create as much as you want. For instance, if you want to create a vector of numbers, there are several ways of creating that. And so, for instance, we could have created the vectors of a series of numbers, a sequence of numbers, random numbers. We could have sampled from a population, and then all these things are there. Maybe as we go along, I'll be demonstrating some of those things. All these things too, we could have also created the vectors of sampling from the characters and whatsoever. But let me see if I should do that, or I should rather go and then also show you how to be able to do a list. Okay. So now to be able to a list, let's come to this and look at what. So that's a vector. So we have logical, true or false. We have integers that we have here. We have numeric. We have complex. We have characters. I have not demonstrated the complex, but for the numeric, it's just about if you have like 5.3, 5 point something, the integers, when it ends with like L or whatsoever, I mean, they are not something. But in any case, if you wanted to have a vector underscore integers, then it's the same thing. All you need to know is that you are using the combine function, and then when I come here, I just do this. So I have 300L or 300. So once the L has to be a capital uppercase, then separated by, I can just say 20 capital L. Once it sees the L, it knows that you are talking about integers. I could have something like 50 uppercase L, that's the proper way to term it. Then 40, you can do that, 40, and then of course the last one should be, let's say 70 L, and then that's all. The other thing you must pay attention is that you cannot end any code with any sign, exclamation symbol, or operational sign. Like you can't end it with plus, or you can end it with like this. I've already mentioned that in the previous video. And then this is how it is. Then you can also have complex numbers. That's where you have a mathematical function. You can use vectors to also create that. And then that may not be necessary at this particular point. Here you are seeing this cross sign here. It tells me that that line, the code is not correct. The syntax is not correct. And it is because of this apostrophe I've already explained. Okay, I could have done this, and you see that it is there. And so the L has a meaning. You can check for that. Now, in creating the vectors, you can create vectors of, maybe this is a very simple way to create the vectors. I want to create vectors of, let's say, using different means. For instance, let's say I have vector 1 here, and then, so I'm creating vectors of numbers. So I have vector 1, and so I'm going to create, so I just have my C here, and then when I do this, if I do 1 is to 10, it means I'm saying that create numbers from 1 to 10, and that's how it is. If I run it, I can just come here and open that. I'm going to have 1 to 10, as you can see it. Okay. Then I can also create vectors by just using random numbers. So I can say I have a vector. I want to create vectors of random numbers. And so what am I going to do? I come here. In any case, the C is what matters. So I have a C here. I'm going to create vectors of random numbers. So how do I create random numbers? Maybe I can use a function. There are several functions for you to be able to do that. So I can use something like run if. What is it? So I have run if. So the run if function comes, and then you just follow it, and you see whatever appears on top here. It tells me that how many number do I want? I want to create, let's say 10, with a minimum number of what and a maximum number of what. So let's say I want to create a numbers of 10. I want the minimum number to be 3, and I want the maximum number to be 5. There's no point writing the minimum and the maximum. Even though when you write, there's no problem, but it's just a repetition. Once R sees this function, run if, it knows that you are supposed to create. The first one is supposed to be the numbers, the second is supposed to be the minimum, and the third is supposed to be the maximum. And then when it sees C at the last, it means that after you have created all those numbers, it's supposed to be a vector. That's all we have done here. And I just run that, and that runs properly. So if I come to print it, if I print this, you're going to see some decimals. All right, so you can see the decimals here. And in that order. We could have actually taken the decimals out. If we didn't want the decimals to be there, we could have rounded everything up. We can just say round. In that case, you have to put a bracket here and come and add another bracket over there. So we are saying that after you have created the whole thing, round it up. Run the whole thing up. So when you run it without anything, so that's going to give you some integers. So you see that it gives you just integers, just like the way it is. So that's how it is. That's how you are able to create numbers. You can create it using this style. You can create it using this style. You can also sample from a population. Okay. So let's say I want to create a vector of sampling by the sampling. And so I'm just going to put this there, and I will just come there. And so I'm creating a vector. So by what? Sampling. So let me just say straight away, I can just say sample. So I'm sampling from what? X is my population. So you can always see this thing on top there. So you see X. The X means that's your population. This one means the size. That's the sample size. Okay. So let's say I have a population of 100 people, and I want to sample just 10 people from there. And then the next thing is, am I sampling with replacement? Remember this probability. if I say the replacement is true, it means it can sample 2 twice. If I say false, it means that when it picks out, it doesn't return it. This is probability. So I'm going to say false so that it doesn't sample any number twice. And so when I do that and I run, so my vector is ready. That's a vector of sampling. I know somebody will ask me, why didn't you do the C? It's the same. So you see that I've sampled just 10 numbers from a population of 100 something. What about if I wanted to also create sample any of the, if I wanted to create a vector to sample characters, is it possible? Yes, it is. So I have a vector underscore character sampling. I have character underscore sample, and then I'm just going to do that. And then what am I going to do? I am going to sample from, so what do? You sample here, you bring your sample first like this, and then what am I going to sample from? A sample starts with the population, so create the population. You get what I'm saying? You create the population before you bring the sample size. So let's say I am going to sample from these individuals. So I'm just going to copy from there, and then I'm coming here to put it there. So what I have done here is that from here all the way up to this place, that's my population. Okay, so this is the reason why it's always good to learn how to create vectors very well. Now I am sampling. The first value is my population, but in this case my population, I decided to create some vector, a vector of characters, or a vector of names of people for whom I want to sample from. So now from here all the way is a vector which represents the population, the first part. So then the second part will be what? So I put comma here. The second part will be what? My sample size. And my sample size, I'm sampling how many people? 10. And then in this case, replacement will be what? Replacement would definitely have to be what? False. True. Because the population, there are how many people? There are just 1, 2, 3, 4, 5. It means that some people have to be sampled more than once. So if you do replacement to be equal to false, it means that you are saying that sample each person once. And so in that case, if we run that, arrow would say that no, the syntax is not correct. Let me try it and you see. If I put true here, it will not run. If I put false there, it will not run. Let me put false here and let's run it. And then you see that it tells you that error in sampling, because it cannot sample larger than the population, and that's what happens. So what you do here is that I will simply come and put here true, and that way it will sample. You see, so that way it samples just properly. So now when you print out the variable, you see that some of them would have been sampled twice. So you see that there's Tangion here, there's Dut here, there's Dut here again, there's Kwanlan here, in that order. And that's how we are able to sample from a character. And then we have also created, it's also a vector like that. And then that's what I was talking about. So we can use different ways to be able to get our, we can actually also come up with like index numbers, like using sequence and whatsoever. And then to be able to create our vector. And then in that order. So this is how we are able to create vector and whatsoever. Now, the next thing is, let's look at, I don't want the video to be too large. And so the next thing we're supposed to look at is, so you can see the vectors. I've given some few examples here. So we are going to look at lists. A list is a combination of characters and vectors and whatsoever. So if I come here, the other data form that R takes a lot is list. So I'm going to come here and then I'll put my hashtags and then I'm going to put the list. And so the list, all that I want you to know is that the list can combine characters, numbers, integers, even vectors themselves. Okay? So for instance, if I have my list 1, so I have my list 1 here, and then I am going to, so what function do we use to create list? Always remember that. So we have the list function. So if I have the list function here, Immediately R sees the list here, R knows that you are talking about a list that you are creating. So R will make sense for what is it with it. And so I decided to create, these ones are always variables that you create. You can decide to call it, you can spell it the way you want. I could have taken the I out. For variable, they are the names. You define the name the way you want. It's on your. So here, I can create a list of, let's say, one, this, and then after that, I can add characters. Let's say something like this. And I can put do it there. I can come out here, and then I can put 30L. You can see I'm just combining almost everything. I can even put one of the vectors there. So I can say vector 1 over there, and that's it. So if I run it, it will run properly. So if I print, it's going to print them different. So if I come and I want to print it, you just highlight it, click undo, just like the way. So I'm going to have my ls1, which is here, and then just run it, and you can see that this is how it prints. This is how it doesn't print them together. It will print the first parts, come and print the character alone, come and print the integer alone, and come and print the last one, then in that order. So this is the difference between list and then vectors. There's not too much for me to say about list, except when we go somewhere and we want to look at how to be able to name our matrix or name our array, then we'll be able to look at that. Now, the next important thing to look at, if we come to look at the syntax we have here, is what is it? Okay, we've looked at list. The next thing we need to look at is to find out whether, okay, so that's the data frames. And I can tell you that 98% of all the data you'll be dealing with in R is in the form of data frame, in the form of table, like it's in a tabular form. You have rows and columns. And then what is it? We need to know how to be able to do this. So I don't know if this video has taken up to like 30 minutes. If it is, I need to stop. Oh yeah, it has taken so even more than 30 minutes. So let me say that this is basically how we are able to create some of these what the vectors, and then we'll create a list. Maybe the next time we'll try and look at how to be able to create a data frame, and then how to be able to create a matrix and then arrays. But once you have basic knowledge as to how to be able to create vectors and then the list, or vectors of different types and then the list, trust me, the rest become easy. How to be able to create a data frame, it becomes easy. The very last thing I want you to pay attention is there are ways to be able to subset some of these things. Maybe I will look at subset as a whole topic by itself. How to be able to subset from a vector, from a list, from a data frame. Maybe after I've done with the data types, then we'll look at that. Thank you, and please, I'm making a passionate appeal. I'm doing all I can to create as much as the most basic way to understand R and then other programming languages on my YouTube channel. What you can do is to also support me by subscribing, or share the video for other people to subscribe, or recommend other people to subscribe. That's how I'm not, and I need your support to be able to grow this channel. Thank you, and God bless you. All right, so shalom. Hope you've learned something. I'll see you some other time. Bye-bye. Watch out for the video on data frames, matrix, data arrays, and of course, how to be able to subset. It's very, very important. And then we would have been done with the most basic part of our programming. Thank you.